Hello, everyone. Welcome to our technical session for November. Right. So remember the rules. Be respectful to everyone in the session. Keep your microphone muted. Engage discussions focused, and avoid spamming the chat. Right. Most importantly, have fun and enjoy the session. Okay. So this is the agenda. And today's session will be on evaluating AI agents and RAG systems. So a brief introduction for our speaker for today. David is an AI consultant and engineer specializing in applied AI systems and agentic architectures. He's a top contributor to Instructor, a popular Python library for structured LLM outputs, and has extensively worked on production LLM systems and multi-agent coordination with startups around the globe. On the local front, David has been contributing to the acceleration of language models for African languages with his involvement with Sabian, Nigeria's first decoder-only model. Give it up for David Okpare. David, you have the floor.
Okay. Hi, everyone. Good evening. Uh, good evening. Maybe if I can get some reactions, I would know that I'm not alone. Okay. Let me share my screen. Just want to know, can everyone see my screen now? Okay. Cool. Uh, cool. Today we are going to talk about evals, and yeah, we are going to focus more on RAG systems, retrieval-augmented generation, and agents. And by now, I'm sure everyone on this call should be familiar with RAG and agents. So I will skip the intro on them. Uh, okay. Um, they have already been introduced so far, but yeah, this is a bit about me too. I'm your friend. That's the most important thing in all of this. So please, whenever you see me out there, feel free to reach out. Anyways, so before I even jump into the technical stuff, has anyone shipped AI features that worked in testing or development but failed in production? Like, can I get thumbs up if anyone has had that problem before? Right. Even though you haven't had that problem personally, there are some people out there, famous people, popular companies, big companies that have had that problem. I've had that problem before. So, the problem that this could cause is there are chances that your system fails silently, and because LLMs are non-deterministic, it means that the input you're given, you may not expect the output you are praying for, right? And most times, without evaluation, you're basically shipping a product blindly. And in production, that's costly because your users are depending on you. You have money, you're burning, and yeah, your reputation's at stake. So, one famous example was Taco Bell. Taco Bell, large food chain in the US, they had to basically re-employ humans because their AI system failed. They had a drive-through and people were ordering massive amounts of things using the AI system because the AI system didn't know what to do or when to um alt on certain transactions and all. So this is one of the small cases where human had to take back their jobs that was already stolen by AI, right? And mistakes like this could have been foreseen or avoided if better evaluation uh, and before it went to production. Because in production, you could explain tire, no evidence, right? So what's the solution here? The solution are to run evals. each component of your application, each component of your system needs its own evaluation. And some people may want to think that evaluation will slow them down and no. However, that's the contrary. Evaluation will help you track issues quickly and move faster so that in production you're not panicking, you're not um, having any issues with your system, right? So, what are these evals that I'm talking about, right? So, evaluation, if you've programmed before, you would think of it like unit test. But evaluation in this case, they are simply systematic tests that measures how your AI model is performing on a specific task, right? So you're basically using evals to ensure that your system is reliable. You're using evals to ensure that your system is stable, and whatever goes in, you are predicting in such a way with your evals that whatever goes in to the model, you know the kind of response you would get out of it, right? And there are different ways to eval. There is offline evaluation, and there is also online evaluation. We are going to speak more about offline evaluation today, um, because offline evaluation is where you do most experimentation. It's faster, it's cheaper, it's safer. Online evaluation is what happens when actual real users are making use of your product, right? So one common mistake is doing one and leaving the other, but it's very important to actually run evals on development side and running evals in production as well. So the best practice is start with offline and deploy with online monitoring. Okay, and if you are familiar with a bit about with evaluations, you may have seen LLM as a judge as one of those topics trending on Twitter or LinkedIn, or code-based evals. So essentially, one of them is deterministic, and the other one is a bit more how will I say? It's a bit more nuanced, right? Um, well, it's a bit more flexible, but you're not always going to expect um it's not as structured or as deterministic as the other. Let me just put it that way. So code-based evals, you are basically making use of like exact match, which could be you're comparing the model's outputs to a certain ground truth, and you're saying, is this one to one? Is it an exact match? You are making use of F1 score, blur, and all, and you're not making use of tokens. You're not making use of an LLM, right? While LLM as a judge, you're basically telling an LLM that, can you evaluate? Can you um, check if this response actually doing the correct thing, right? So LLM as a judge will cost you a bit of money because you're paying an LLM to do it. And code-based evals are things that you could run using Python code or JavaScript code, right? And so let's just go through the typical journey of a RAG system. In a RAG system, um, you give a user gives a query. The query is then rephrased or reprocessed, and you then send it to a retrieval engine. And the retrieval engine could be like a vector search, could be a full text search, an hybrid search, whatever suits your case. Uh, and you retrieve the context, you give it back to an LLM to give you a final answer. Sometimes you may add like a re-ranking step to reorder the retrieved contents, right? So in this case, each step that makes up the RAG journey needs to be evaluated, right? Sometimes queries need expansion, and all. And you need to see if this query that was given actually makes sense, right? The final answer, you need to figure out, does the final answer make sense? Is it correct, right? The retrieval step, very important step, making sure that you're actually getting the right context out of the retrieval system. So all of these steps needs to be evaluated separately, right? And okay, I think I've touched on this. So basically, the retrieval step, evaluating the retrieval step, we are basically meaningful going to focus on retrieval and generation, because those are the two most important steps in your RAG system. So in the retrieval step, we are making sure, did we retrieve the right documents? Are we retrieving, are the relevant documents, are the correct documents ranked high, and the non-correct documents below or not even included at all, right? And the generation too, we are making sure if the answer is correct, the answer is grounded to the context, the answer is useful to the user too. So to make to there are certain metrics that we can use to um, judge or base our answer upon, right? And one of them is the precision K. And precision K is simply um, the retrieve context, the retrieve documents, how many of them are correct. K is the number of retrieved documents and how many of them are correct. The recall at K is in our entire database or in our entire vector space, how many of the documents that are correct were actually retrieved uh, when we gave our retrieval question. And we have MRR, we have NDCJ, and all of these are complex. But today, and the most important ones are precision K, precision at K, and recall at K. Matter of fact, the most important one out of these two is recall at K. You need to make sure that out of your in your entire vector space or in your entire search space, you're retrieving all the documents that are correct for your question or are relevant to your question, right? And for the generation step, we are making sure that the answer that the model is providing is faithful, is not hallucinating, it's correct, basically. Is the answer relevant to the question? Is the answer factually correct? Like the LLM could give its own answer, so you need to make sure, is it grounded on the context given to it? Does he utilize it properly? Okay, so the next thing we are going to explore is the journey of an agent. The journey of an agent is a bit more complex than RAG. Okay, so agents are not as linear as our RAG system. They don't follow like the one-to-one steps of the RAG system. An agent could decide to step back. By step back, I mean like retry a step once again, right? The agent can plan. It can decide to select various tools. So it's not structured or as linear as the RAG agents. So for the agent step as well, we need to make sure that each step of the way is evaluated, and not just each step, but we also need to evaluate the journey itself, the journey that the agent takes to go from one step to the other, and making sure, okay, is the agent actually using the most effective or the most or ideal path, or is he using like a longer journey to get to the answer? So all of these steps need to be evaluated separately. Okay. And okay, yep, this slide touches a bit more on the differences between the two. Um, yeah, like the RAG agent is, I mean, the RAG challenge is a lot more deterministic. The agents multi steps, multi tool calls, can loop, can self correct, can retry, different paths to an answer. All of these are challenges that comes with an agent. So to evaluate the two systems, it's a bit similar, but with a bit of with some differences with them. Okay. So when evaluating an agent, we may want to um, evaluate the tools that the agent made use. We may want to evaluate those tools. Did the agent choose the right tool? Did the agent um, went through the right path? Did the agent provide the right parameters in its tool call? And the final answer too, is the final answer correct? Is the final answer helpful? And no. So one simple prompt that we could use to um, for example to testing the tool calls. Now we could use this simple prompt, giving an agent task and the tool call evaluate based on this task, the tool that was selected, the parameters that were given. Is this the correct selection? Yes or no? The LLM would tell you yes if that's the right thing to do, no if it's wrong, right? So in production, your life cycle mainly will consist of using real data, and the real data um, could then be evaluated, can then be evaluated before you then pass through like a CI/CD, which is similar to the concept of unit tests or integration tests in programming, where you would, before you push any changes to production, you're actually making sure that your nothing is broken. You're making sure that the LLM still provides the right answers, the right context to the new changes you make to the prompts, uh, to the agent workflow. So those steps need to be done. This is basically when building a product, you should adopt all of these steps. Okay, so let's move to something more practical. I guess I've been talking for a while. Is there any questions before we go into like a notebook and start to see codes? No questions? Okay. Okay, cool. No questions. Then let's go and see code then. Let's first start with um, the RAG evals. And for this, I've already loaded a data set. And this data set is basically Wikipedia questions and answers. And I'm also going to make use of BM25. BM25 is a full text search engine. It's similar to Elasticsearch. And yeah, instead of using a vector database, I decided to use BM25 instead. And I'm also going to write an LLM as a judge. And the LLM as a judge, I'm going to use like a simple LLM call using Pydantic AI framework and all. And we will explore the precision, recall, and faithfulness. Okay, so this step is mainly for setup. Um, And yeah, I'm also loading the data set, downloading the data set from uh, Hugging Face. And I've already loaded the data set here, so I don't need to go through it again. But let's explore the data set a little bit. Okay. So in this data set, they've given us correct answers, they've given us wrong answers too. And in this question, okay, I see an end raised.
Hey, David, looks like you have a question in the chat.
Oh, okay. Why did you use BM25 over vector database? Okay, good question. Well, so it's more of a personal choice, but also it is um a choice based on evidence. So BM25 is fast, is cheap, and can also give you similar performance to a vector database. So instead, when building a RAG system, your first choice shouldn't always be a vector database, embedding chunks and all of that. Try to use BM25. And if BM25 is limiting you, and you're running your evals and you see that BM25 is failing, you can run evals on similar vector comparison. Well, you could run your evals on vector embeddings and see if you're getting better results. And if you're getting better results, you can switch to vector embeddings. But personally, in most of my newer projects, I first use BM25 before I go through embeddings. Does that answer your question? Okay, how does BM25 work? I guess that's beyond the scope of this class, but BM25 is simply like Elasticsearch. If you know Elasticsearch, it's similar to BM25. So what BM25 actually does, it will first tokenize the query you are asking it. Let me see if I have an example here. It will break your query um, into tokens, and it's going to do like a similarity search or a full text search, basically going through each of the um, going through each of the embedded chunks, I would say, going through each of the embedded chunks and seeing which chunk contains a lot more tokens. So the BM25, when it's tokenizing, it will break it down into chunks, into tokens, sorry. Then it will compare in this our vector database, in this our BM25 database, how many of these tokens are similar. So that's pretty much a quick overview about it. So in our data set, sorry, we have some RAG questions, we have the ground truth answers, and some of them are incorrect, while some are correct. And we want to use we want to use evals in this case to uh, identify which questions are correct, which questions are wrong, and then we can eventually annotate the data and try to figure out why did the LLM provide the wrong answer, basically. So um, that's what we are going to do in this notebook. And yeah, in this case, we have um, in this case we have embedded the database, embedded the data sets. We've built an index for it. In this case, we have 460 passages, and we've indexed them. Um, then we would use uh, the BM25 to retrieve. We'll first give it a query, then we would ask the retriever to return a certain number of chunks or passages. Then we would compare with our with our ground truth data to see if um, there is some similarity, and the ones we determine similar, we are going to compute our precision and our recall. We are going to give it a score that, okay, this is correct. This has an intersection. This is similar, right? So we are basically computing similarity scores on them, and we are running the maths to basically see how many of the retrieved passages are relevant or correct, uh, and we are also going to check how many of them were ranked very high. So that's the recall and precision. Okay, so yeah, we have a way to compute the similarity using Jaccard similarity. Very simple similarity, nothing too fancy. Um, we also have the ground truths, and yeah, we are computing the precision here. So in this case, we say precision is the number of relevant information in the retrieve passage. The formula for precision is the number of relevant passages in the retrieve context divided by the retrieve context, so, which is, yeah, this is a formula here. And we are running it, returning a score as well. Same thing with the recall. The recall is the number of retrieve contexts divided by the entire number of documents or results in our vector space or database, right? So the recall, most especially, if you have a bad recall, you have a bad system, right? If you have a bad recall, don't even proceed to go compute precision, because that will be worse. So make sure that your recall is good before you proceed with anything else. Okay, so yeah, I've computed a few examples. I've retrieved a question based on this particular question. I've retrieved passages based on this question. Sorry, and yeah, these are the top three. The BM25 is giving me some scores. I don't really care about those scores. I trust my evals more. And in this case, the precision is one, right? That's when I'm getting one document. But like I said, precision doesn't really matter, right? The recall 0.5, that's bad recall. Um, well, not too bad. 50% accuracy, not so bad. Um, when we are increasing the number of retrieved documents, the recall jumps higher, which is good, because now we are saying, like, in every three documents that you are collecting, 100% of the time you're getting the right answer, right? And that's a good score. Uh, Precision at 5, great. I mean, precision at 5, not so great, but we don't really care about precision. We are more focused about recall, because recall means you are basically getting all the documents that are relevant to your answer in from the database, from the vector database. Okay. And yeah, so now we are basically running the entire thing on the entire data set. The first example was on just one data set, and we have the following scores. Uh, Recall at, when we are recalling three documents, uh, the scores is 0.935. This is using BM25. Maybe using vector embeddings, you'll probably uh, this numbers probably move up to about 950 or so. But with BM25 as a baseline, we are already getting very good score, right? And at 5, similar. When we are retrieving 5 documents, we are getting very good recall. At 10, we are getting even better recall. Okay, so that is pretty much it about recall and recall and precision. And now to check faithfulness and correctness and helpfulness, all of those metrics, as much as they make sense, you actually need to define um, what you mean by faithful, what you mean by correct, what you mean by helpful, right? So when you're writing your LLM as a judge, you need to give good heuristics, you need to give good rules to the agent on what stands as correct, what stands as faithful, what stands as helpful, right? So in this case, I gave very simple instruction to the model, but when you're building when you're building a production system, well, after this class, right? Go out there, experiment with this, give it more rules, give it morals to determine what stands as faithful, what stands as helpful, what stands as correct. So this is just a base prompt that I use here. So we then prompt the model, we give it a question, we give it the context, we give it the generated answer that we got from the model, and we are asking it, okay, is this answer faithful or not? If it's faithful, tell us yes. If it's not faithful, tell us no. And we have some scores here. The model says for the majority of things, we are faithful answers. There was one that is not faithful. Okay. There's about a few answers that are not faithful. Yeah. Okay. And yeah, you can then visualize it properly and see 10 of my answers were not faithful. That's 40%. This is very bad. 60% of them were faithful. Now you can take this metrics and go back to your prompt, go back to your LM prompt, adjust things, the adjust the rules that you give to the model so that the model can then improve its answers, and you basically run the evals again. So evals is not like a one-time thing you'd have to do. You take the result from your evaluation, you go back to your system, you try to improve your system, you run the evals again, you until you are satisfied. But it's more like there's no satisfaction in it, if I'm to say, because systems in production are exposed to various nuanced examples. Your users could ask crazy number of questions. For example, in the case of Taco Bell, that someone asked 10,000 bottles of water, like the agent's supposed to have been smart enough to know that, okay, maybe I shouldn't sell 10,000 bottles of water in the drive-through. Doesn't make any sense. So you need to test it, run it, put it in your development loop as you're working on features, as you're trying to improve your system, you keep running evals. Okay. And sometimes we may say, okay, I don't have anyone using my product right now. So how do I run evals before launching? Right. And for that, you can make use of synthetic data. And I think I have a slide that speaks a bit more about synthetic data, but what you're essentially doing is you're basically role playing or mimicking the expected behavior from your users in the development phase, and you are asking the model, you're asking the RAG system those questions, and and trying to gauge the model's performance on your synthetic data, right? So your synthetic data is mainly when you don't have any users, any real user queries to test on. You can make use of synthetic data to move quickly. Okay. And yeah, so this is pretty much about RAG evaluation. Let's move to agent evaluation. Agent evaluation is a bit more different because now we are measuring, or we are evaluating the tool selection, we're evaluating the parameters extraction, we're evaluating the path to convergence. The path to convergence is basically the journey the model takes to get to its answer. So you want the journey to be as efficient as possible, making sure that your agent is not spending so much money on one task, right? And also measuring the final answer to see if it adapts or adheres to your rules that you gave it. So similar to here, I'll first run my um, setup and configuration. I have an agent defined here, and it's a simple prompt. You're an helpful assistant with access to tools. Use the tools to answer accurately. Okay, and we have a calculator here. We have a Wikipedia search. I mimics the answers because I don't want to use the internet. No, so I just gave a few answers here for it to, um, yeah, to basically answer. For this test, for this class, we have a date lookup, and a unit converter to convert from one unit to the other. Okay. And we have test cases. Yeah. Let me explain about test cases. Test cases is very important. In many of your evaluation libraries or frameworks, you will see they call it as data sets. And this data set or test cases, they are mainly used to give scenarios to the model. So basically, case, I tell the model that for this question, this is the expected tool that you should call. And if you get that particular tool, should be successful. Um, yeah. If you get a very another tool, maybe you should make it as failure because we expecting this question to result to calling a calculator tool, right? Um, and I have multiple cases here. I have cases where I'm expecting the model to make two calls, multiple tool calls. I'm expecting the model to fail with certain tools. And no, okay. And yeah, that's pretty much it for the data sets. And now I am running the agent on this data set and actually seeing how it works, how the agent performed on these cases. And for this case, the agent basically excelled at every one of them. Every test passed. But there are some cases where the agent um is not going to what's the name? It's not going to make use of the right call. Okay, let me try to make it fail here. I'll probably tell this to call the Wikipedia search. And yeah, hopefully it fails here. Okay, let me say failure. And when running this, it should fail because the agent's supposed not to be calling Wikipedia search for a calculation. But I'm basically triggering the agent to fail in this case. Oh, it didn't call any tool. That was smart. But yeah, it's okay. Maybe I'm not running something properly. Just okay. Okay. Where is this? Where is this? I'm not running it properly. Um. Okay, I'll figure this out after this. Let me just rush through these slides, and yeah, I can give at the end of the day after every um trace after every trace done with an agent, one thing you want to do is to actually look at the results and annotate them. This is a very important step. Why? Because you want to keep track or log information that um, about how the agent is performing, either in production or in development. You want to keep track of it. That way, whenever you come back to wanting to fix your agent, you can have like a document of the set of tasks that you need to look up. And when you're also running these agents, sometimes you have agents that call multiple tools or agents that run through multiple steps. One thing you also want to do is to also uh, first fix the first downstream errors. And the first downstream errors is basically you have two agents in a chain. The agents, okay, let me use you have three agents in a chain. And the first call fails, the second call is most likely going to fail too. So instead of trying to fix the second call immediately, first fix the first one. That way, once you're sure that the first one is correct and the second one fails, then you can come back and fix the second one. But make sure that you are evaluating or fixing things in a uniform pattern. Like, don't just jump from one phase to the other. Follow the trajectory of the agent to fix the issues. All right. So, any questions so far? No questions? Okay. Let me go back to the slides and try to finish up this. Um, so, to put it all together, agent should be like a one step or one process in your entire development journey. In the development phase, when you write your code, create an eval data set, basically could be from real users' logs or from synthetic data, put it all together, run offline evaluation, iterate through the metrics, and make sure you are boosting your agents to reach your targets. In the pre-production, when you're deploying your code, you could make use of CI/CD, and in production, you can make use of observability tools to log your users' information. Uh, I'm sure when I'm saying logging your user information, you'll be like, okay, data privacy. But you can make use of PIIs. PIIs is, well, I'm not sure of the exact definition of it, but it's basically to remove any personal information about a user from from their data. So if the user is sending their bank information or their real names and all, you can remove all of that. That way, you are running evals without any bias. Okay. And you can also monitor the metrics in production and seeing if your agent is actually running to task. Your agent um, is not failing on your metrics in production. And you can collect new edge cases because in production, your users are going to use it differently than you use your product. So they may try some nuanced things, they may try some things that you've never expected before. So collect those new traces, collect those new edge cases, log them properly, keep them aside, and make sure that you are evaluating, right? So the key takeaways here is evaluate each component. Don't just test end to end, but evaluate it each one of them that makes that make up your LLM workflow. Evaluate each step. Use the right metrics. You may want to use LLM as a judge for more nuanced things, for things that cannot be deterministic. For example, the trajectory that your agent passes through. That's not very deterministic. You want an LLM judge to evaluate that. You should also make sure that you start with offline evaluation. It's faster to do offline evaluation than production and then online evaluation. So make sure you set both of them up, but start with offline evals and make sure to make use of observability tools, iterate through your evals. Evals is a loop. Always evaluate your system. It's not just a one thing that you package, you ship. No, you always have to iterate through your evals. And the first error you see, focus on that one first before you go down the rabbit hole and trying to focus other errors. And good evals means confidence in shipping. And yeah, that's pretty much all I have. And okay, one last point, yeah. Whenever you're running evals, you should also try to eyeball the data by yourself. Don't just give everything to the LLM to do for you. Try to go through the data by yourself, look through it. Is this actually making sense? Can I trust this evals? Yes, you also need to make sure that you can trust your evals, making sure that what you're saying is faithful or what the LLM is saying is faithful. Is it actually faithful? Right? Be the judge of what the LLM is telling you. So, thank you. And yeah, any questions? Any questions? Okay, no questions from anyone. Or should I be the one asking the questions?
All right. Thank you very much, David. Really enjoyed the session and the importance on evals, right? So thank you everyone for joining to today's session, right? All right. So our upcoming events, our study group is still ongoing, and we'll be having our office hours in December and also our machine learning community day. If you haven't registered, please make sure to do it. It's going to be amazing. It's our first in-person physical event. So we're looking forward to that. If you have any feedback or on the session, right? The link is on. Sorry, Nancy, do you have a question? I'm seeing you said ask, please, like a minute ago.
No, I don't.
Okay.
Bishop, my class are more.
All right. No problem. Thank you. Can turn off your mic.
Yes,
So I have shared the feedback link.
analysis, did assignment to the
So
submit on the first.
please,
You get one PDF and I see now.
Assignment. Analysis.
please make sure to give feedback if you have any, and to register for the machine learning Lagos physical meetup, our community day that is. So thank you everyone for joining the call. Have a good day and a great weekend ahead. Raul, you have a question? Raul? Okay, looks like he has left the meeting. Oh, are you there, Raul? All right. No one's there. Okay, everyone, have a great day. See you later. Bye.
Hello.
Yeah, hello?
Yes.
Okay.
Everyone has left. Good evening, sir. So, concerning the materials used for this literacy, I don't
Data science, Abi.